So this is a series of debates. Each debate should be around 15 minutes. The first part of the debate will be a debate between John and myself. And then we will open the debate to people either on the inside or on the outside who want to make a contribution. We are going to defend, each of us, one side of any given debate, but the side that we defend will not necessarily correspond to the side that we believe in. And I think we will alternate. So I will get to choose which side I go on with the first debate, and John will then choose which side he wants to go on in the second debate, and so on. Even then, even if there are two people who both want to defend the same side, that will not be possible. I would say philosophy is indispensable to ontology engineering. And the reason for this is, after long experience, I have discovered that there are a whole series of errors which ontology engineers in the narrow sense are disposed to making. And the only way in which, and this is not going to work in every occasion, but the only way in which we have even any hope of removing these errors in the thinking of ontology engineers is by giving them courses in philosophy. Now, I'll give you one example of a very commonly repeated error made by ontological engineers, or by software people or computer scientists more generally. I think it was a great surprise on my part to discover that this was a widespread belief among computer scientists. I think it is still the case, although I haven't had much recent evidence that it's still the case, probably because they all avoid me like the plague. So the error is the belief that there is no such thing as truth. And the reason why they believe this is because faithfulness to the truth is actually an obstacle to ontological engineering, because it makes your job of creating software to support your ontology engineering much more difficult. So when I started working on ontology with computer scientists or with people with some kind of computational background in the world of bioinformatics, the biologists I worked with, although they didn't talk much about truth, they did in fact believe in truth. Where the computer scientists insisted that there is no such thing as truth. Truth is a matter which should be replaced by something like consensus belief, or by something like is able to be programmed on a computer, or by something like who cares about truth? We just need to have simple models of reality, because that makes our life as software builders easier. Now, I'll give another example. I could go into the debates I had with quite famous people on that topic, but that would lead us too far afield. Another example is the use-mention confusion. The use-mention confusion says that there are two ways in which words can be used in a sentence. One way is if you actually use the word. For instance, when I say sleep is something that you do at night, and that may be true or false, but still it's a good sentence. There, the word sleep is being used. But if I say sleep has 6 letters, then I am not using the word sleep. I am mentioning the word sleep, which is often expressed by quotation marks. And so somebody who doesn't know about the difference between use and mention might say things like, sleep is healthy and has 6 letters. And they don't say that, of course, because even they know that that is, from an English grammar point of view, nonsense. But they still make mistakes, which are use-mention mistakes. And an example would be the definition of mouse. The definition of mouse in one of the biomedical ontologies that we worked with in the olden days. Mouse is defined as, sounds so bad that I don't even believe that this was the way it did, but they did it. But mouse is defined as mus musculus. Now, mus musculus is the Latin name for the species of mouse. It's a name of something, and a mouse is not a name. There are lots of examples of use mention confusions in definitions in early ontologies. Most of them were eliminated. Now, another confusion made by ontology engineers and by similar characters on the computer science side of the world is the confusion to believe that what ontologies are about is not the world or entities in the world or reality. Rather, ontologies are about concepts in people's heads. And this confusion goes hand in hand with the use mention confusion that I referred to earlier. So if you believe that ontologies are about concepts, then you have to work out what you mean by concept. And if you mean by concept an idea in the mind of some human being, then you would have to say that, for instance, mouse in the ontological sense, so the ontological definition of mouse means to be an idea called mouse in the mind of a human being. That is clearly not a good way of understanding what mouse means in an ontological context. Mouse in an ontological context, I believe, means a type or a species or a kind or a universal. And then the way you define mouse from that point of view is by saying X is a mouse if and only if X is an instance of the universal musculus. I think that's probably enough for you too.
All right. So I certainly don't want to dispute any of those examples. There are plenty more. People make these mistakes all over the place. People, even ontology engineers, confuse things like Algeria for a class. That was a recent one. So I don't want to dispute that. So the claim here, philosophy is indispensable for ontology engineering. What I've taken away from your position, though, is not philosophy per se, but good philosopher doing good, systematic, disambiguating, careful analysis of meaning, not necessarily philosophy, but I can fit this into a bigger story, and I think it's important to do so. So I think we both agree ontology engineering is not on the way, will be on the way to becoming a science. Catherine wheel spinning out as philosophy is in its own discipline. Philosophy is important in early days of disciplines that spin off, much like Newton was reflecting on these sorts of things. I mean, Chomsky, not too long ago, arguing in print with philosophers, Hillary Putnam, before creating linguistics journals, right? Arguing over disambiguating terms like L language versus EI language, right? Like the language of grammar in the mind versus the language of spoken, which was commonly confused in debates in linguistics in its early days. Insofar, I think, as philosophy might be indispensable or necessary to ontology engineering, it's in the same sense as any science required, at least initially. So philosophy, I think, in the early days of any science is necessary to get clear on what the contours of the discipline are, where to focus, where to generate consensus around training, Kuhnian revolution style. But after that, it's not clear at all to me that philosophy would be essential or relevant to the actual practice of the engineering work that goes on. Is philosophy necessary for good physics to be done right now? Not all of it. Maybe Hawking's at the outstretch, like on the boundaries of research, you'll find it there. Linguistics on the boundaries of research, you'll find it there. But not in the tradition, the engineering practice, the day-to-day, the ontology engineering practice. So what I'm saying here is on the bookends, philosophy is going to be important, philosophy is relevant. As we emerge out of this department, out of this discipline into our own, be clear about what exactly it is that we're studying, then we're on our own. I don't know that philosophy is relevant there. Early days, boundaries of research, maybe.
There are various different options here. One option is the idea that philosophy was necessary, but we've already got the Catherine wheel effect going. Mm-hmm. So the Catherine wheel effect, for those of you who haven't heard of it, is the effect which goes something like this. Aristotle creates theses about living things and about movement and about kinds and instances and so forth. And some 2,000 years later, Aristotle's ideas of physics, as interpreted by people like Newton spins off the science of physics. Newton was a philosopher. His main work on physics is called Philosophia Naturae or something like that. And similarly, the world's first psychologists were philosophers. The first journal of experimental psychology was called Philosophical Studies in German. And the first economist was Adam Smith. And Adam Smith was a philosopher, and so on. There are various other examples of this Catherine wheel effect where philosophy throws off other disciplines. Now, I do not believe that philosophy is throwing off the discipline of ontology, because so many of the structural terms which ontology needs to use, terms like instance, species, universal, relation, definition, and theory, and they're all philosophical terms. Physics is dealing with things like energy and mass and velocity, which are not philosophical terms. So from this point of view, ontology is not spun off from philosophy. Ontology is part of philosophy, the most important part. It is first philosophy, as I think Aristotle said.
How do you draw the line between philosophical terms versus non-philosophical terms without begging the question? Why is
I don't need to beg any questions. We all know which are the philosophical terms.
Do we?
They've been dealt with by philosophers for 2,000 years.
Well, I mean, the same thing. I mean, the Cartesians were saying the same thing to Newton when he was writing his works and trying to model celestial mechanics. It's like you're doing
So
philosophy.
it's the other way around. How do we decide which terms belong to physics? Well, physics has been established thanks to philosophy. Physics is now an independent discipline. It was indeed spun off, and it gets to decide how energy and velocity are defined.
That's right. And
Now,
I think
the ontologists can't be left alone. The ontological engineers can't be left alone to define terms like definition and theory.
but we can. We just haven't. For 15, 20 years, there's not been scope around what our discipline is. I was in Brazil 2 years ago and I asked the audience, I said, why is what we do different from data modeling? Why is it what we do different from conceptual engineering? And nobody could give me a good answer. Or this year I gave them an answer. And the whole point was to identify scope for the domain so we can train people towards the ends of that domain. We just hadn't done the work. There just wasn't
Yes, so
Chomsky to
what
come in and lay down.
I
this
would
is
say
what
that what you were doing was teaching them philosophy.
No, teaching them consensus so that we can identify what
So
exactly
it's
is.
arbitrary that they are
Not arbitrary,
boundaries of
certainly important, motivated. Why? Interoperability is a goal. Data quality improvement is a goal. Systematic disambiguation of data, like that's a goal. And we do this through the kind of conceptual work.
I would say that some fraction of what you just described would indeed belong properly to computer science. I would not claim that data, for instance, is a philosophical term.
Yeah.
But information looks to me like a philosophical term.
And how do you draw the line? Tell me why information is philosophical, but data isn't.
That's a hard case. So there is no clear line. It's going to be a vague.
I'm on board with, I mean, the world is full of mystery, but if we're providing.
That's a very weak move to make.
It's yours. You're like waving your hands. I can't draw this boundary, but we're trying to draw boundaries between philosophy and everything else.
You are.
I'm just saying, ontology engineering, at some point after it's spun off, is not really obviously, perhaps not at all, going to have anything to learn from philosophy.
It's going to have the bases or the basic components of its theories and of its approach and of its training be evidently related to philosophy.
But every discipline, every science is like that too. Every science.
It's not explicit in the way in which it is.
A lot of like Newton.
The very name of the discipline comes from that.
I mean, the name, like, let's not be tripped up by labels, right? I mean, at some point, every scientific discipline engages in some sort of rational argumentation. They pull those terms from philosophy, like critical analysis, like physicists argue mathematically, logically. Does that mean that they're
Did you read
mathematicians?
Feynman?
Yeah, I'm familiar with
He
Feynman.
says exactly the opposite of what you're just saying.
Physicists who train, like physicists, you take a physics class, you learn their methods for like modeling trajectories and stuff like that, using geometry and algebra. There's a series of proofs that you work through, proofs that are logically connected, not connecting propositions to other propositions. Does that mean that physics is in bed with philosophy and logic? Yeah. Insofar as then the claim would be logic is relevant, indispensably relevant.
Yes.
So that I'm on board with that philosophy insofar as it's relevant to ontology engineering. It's relevant in that sense. But is that the only sense you mean? I think you mean something stronger than that.
I mean something a lot stronger than that. But now I'm beginning to think that maybe physics requires some philosophy.
Well, I can see the push that way. I can see the push. But I think part of the reason here, at least for me, is we don't know, we haven't described what philosophy exactly is. So what is philosophy?
So far, as a moderator, I might ask to clarify the term philosophy used so far, because it seemed to be something related to philosophy of language, logic, metaphysics, but not to aesthetics and ethics at the moment. Maybe they are relevant, maybe not, but usually they are in the ballpark of philosophy. So are they relevant for ontology engineering as well?
I don't think I ever in my life attended an aesthetics class. And I'm sure I never attended an ethics class. I was very careful. So yeah, they are sort of fringe disciplines, some disciplines in the grand whole of philosophy. But determining what the limits of philosophy are is indeed a difficult. Which discipline is going to do that other than philosophy?
I mean, I think philosophy would. My understanding of philosophy is broad. It's the study of methods around which, or like the study itself of methods in attempts to address questions that we don't know how to solve, or we don't even know how to approach. We don't have the methods on how to approach. And so when we get clear on those methods, those fields become sciences. So
yeah, I think that's wrong.
Well, I mean, tell me where I'm telling lies. This is what happened when Newton laid.
You're telling us what philosophy is not. You're not telling us what philosophy is.
He laid with the studies of methods. It's open, like
Those methods that
like if we lay them out and identify which ones are valuable and which ones are not. So,
in order to identify methods, we need technical terms, and those technical terms belong to philosophy. And if you want to identify the methods of an experimental physicist, you will need technical terms, most of which have nothing to do with philosophy.
This equation, does that belong to
That's
philosophy?
mathematics.
Correct. This line and point.
That's mathematics.
So was Newton not at all doing philosophy? Because he did his whole.
He was one of the people caught up in the Catherine wheel. So
well, he was doing.
he was pulling himself.
All geometry, right? Lines and points and whatnot. Like the Philosophia Naturalis.
I think that there is a lot of philosophy in Newton that it would be embarrassing to read.
I'm sure that is true. I mean, I hope nobody looks back at my philosophy and thinks there won't be anything there like that, for sure.
But will it be philosophy if these methods are then found? And for time t in the future, it will be scientific, let's hope, if it's a good hope. So your definition has a variable, basically. So things that are classified as philosophy will change. So maybe at the Newton time, they were philosophy. And this also as an assumption that disciplines can change in time. Is it true for you, Barry? For example, disciplines, whatever discipline, biology, chemistry, calligraphy, can they change in time? And if so, how can they change? Can they improve, for example, the extent we have?
Yeah, I think this is a philosophical question. So the question of what is a living thing is a philosophical question. All of the sciences change, in part because we have technological advances which make it possible to ask more questions and get answers. We don't have that in philosophy. I think I just
in ontology engineering.
yes. So I don't want to make the claim that ontological engineering should be a part. What I want to make a claim about is more the necessity that ontological engineers should have a grounding in philosophy, so it should be part of their training.
Yes.
And then the question is why? Physicists don't need a ground in philosophy to do good physics. Does anyone here or online want to make a contribution? No one wants to make a comment? All right, so someone over here wants to make a comment.
So let's say what John was saying is accurate, and this is Catherine will effect, and we've identified an ontology engineering proper scope for the discipline, and it is more like physics, more like a science than it is now, and so there's not obviously a need for a philosophy training. So I think that's something that is always going to be the case, and it's sort of, in my experience, crucial to master ontology engineering. It has less to do with the technological implementations or applications, and less to do, honestly, with those like semantic disambiguating, and more to do with helping people, helping stakeholders and sponsors identify the right questions to ask. And that to me is very Socratic. That to me is very much a how do you answer the right question or ask the right questions, and how do you help somebody ask the right questions. Once we can get through that, we're good. But I think I see that as philosophers are very good at that. We're inundated by fascinating questions. We don't get overwhelmed by them. Our viruses are alive. Great question. Fascinating question. Probably not relevant to most modeling of data around about viruses. Let's put it aside. And I can do that easily. Students can do that easily because, again, I think we're inundated with these fascinating questions, and we see which ones are relevant and which ones aren't. And we have this Socratic training where we can help mediate and midwife those questions out of sponsors.
Good. So I started by attacking the concept orientation in philosophy. Concept orientation in ontology. The concept orientation in ontology goes and went in the people I was talking about hand in hand with a rejection of philosophical realism. So to deny truth is also to deny reality. And there is a movement within philosophy which denies reality. It's the most sexy. It's very popular in France, particularly because it's so sexy. And one goal in training people in philosophy, in my mind, is to teach them to avoid those nonsense doctrines that team up around philosophy in the fringes in Paris and places like that. So actually, my own view is not that philosophy is irrelevant to ontology engineering. It's that realist philosophy is what ontological engineers should have baked into their brain.
Yeah. I can agree with that. And I can agree in the same way Armstrong, good metaphysics. That's our aim.
David Armstrong.
Data.
All right. I think we can finish with that one. So I don't know that either of us won.
That was good. It was a good conversation. We're not, this isn't a win-lose thing.
All right. So I choose to defend this. Is it my turn to choose?
Yeah, well.
I choose to defend the view that mappings are a bad thing. We should avoid mappings. And I know that most of you spend your life building mappings. So this is a special case of the good cop, bad cop opposition. So the world of ontology includes a large fraction devoted to negotiation. So you put forward an ontological proposal to solve a certain problem, how to determine whether viruses are living things or not, or whether they're organisms, or whether protein complexes are proteins for the purposes of the protein ontology. These are typical questions which ontologists have to address. My methodology in addressing those problems, and there was a time where I really did play a role in addressing those problems, was the bad cop approach. Namely, I would just shout at people and humiliate them and explain why we have to make a choice and we should make this choice. maybe we could make the other choice, but if we split and have two groups of choices, then we're going to fail to create good ontologies. And so we should just accept one choice. Now, that could be the choice I make, but the job of the bad cop is to make sure that everyone accepts the same choice. Now, the good cop, like him, he points to Beverley, would say, no, we can have one ontology that these people embrace, and then we can have this other ontology or four other ontologies, which those other people embrace, and then we build mappings so that everything that we can say in the one ontology, we can translate into the terminologies of the other ontologies, and then everyone is happy. And my argument is that, first of all, that will work for the first iteration. But then ontology number one will have a new version, maybe in 6 months' time. And ontology number two, where they are still doing their job properly, will have a new version in 1 year's time. But ontologies number 3, 4, 5, and 6 won't do versioning. They'll just make random snippets of changes into their ontology content and perhaps publish the fact that they've made these changes, but they don't follow the rules. They don't have versioning. Even if we do have versioning, the versions will appear within different time intervals. And so there will be issues when ontology number one has not changed, ontology number two has changed. Do we change the mapping or not? And what happens when ontology one does change and ontology two does not change? Do we change the mapping again? And who will keep track of all of those changes? Ontologists are busy people. And so we should not encourage people to build mappings. Mappings are a well-known failed paradigm. It never works. It's impressive in the first initial presentation of the mapping, but then no one cares, and the mapping dies as soon as you have versioning going on.
All right.
QED.
Not quite. So I can concede a lot of that history. And I think part of the reason that part of what you're picking up on is that ontology mapping research has been terrible. I've never read an ontology mapping paper that I thought was good. It's all garbage and useless to me. And I'm saying this as an engineer from an engineering perspective. When I think about the utility of a mapping, it's something that I can feed into code, something that I can use. I need to switch perspectives in some way. I need to transform syntax from one syntax, and no literature out there is even pointing in that direction. So when I'm thinking of mapping, I'm thinking of a future state, the work that like Giacomo and the team with Tim Prodham did with the provenance ontology mapping, the BFO, the stuff that the FEM group is doing with BFO, the stuff that the GIST group is doing with BFO, and ultimately what the IAS and BFO working group will be producing, something that I can feed into a machine. Now, everything you said about versioning, though, still stands. But to me, we just need better configuration management. In our literature, the research is not even approached thinking about mappings as engineers. What they do is I've seen them, they sit around, they argue about whether this term means that term. They don't build OWL files. They put annotations that say this is like that. They use something like the schema, narrower than, broader than, but that's not what we need to kind of do that. And what we need is something more rigorous, something more precise, something that is isomorphic mappings and injections from one space into another. Maybe the introduction of new classes that weren't there to begin with, to combine old classes or expand to create new ones, something that's consistent with the previous ontology into the new ontological space. Now that is what I'm talking about with mappings. And I think one, like this is just the engineering side of it. If I look at it from the perspective of the good cop, bad cop dynamic, it is true. You would be fantastic at the bad cop. Nobody can question that. But you're only one person, and we can't train more berries, right? Like there's Barry and there's Barry. And so this other strategy, you say good cop, but I look at it more like surreptitious cop. Because what happens in these exercises, the GIST team is a good example. We do the mapping rigorously, carefully, showing where they project in our space and where we project in ours. And then ultimately, they say something like they did, which is, we were confused about information. We need to change our model. It's very clear why we were confused. We've been arguing about this for 2 years though and didn't see it. So I think with a good theory, with a really good ontology, and BFO is a really good, well-axiomatized, well-understood ontology, mapping into that, I think there's there's a sense in which you're not wrong about giving life to bad ontologies, but there's also a sense in which we're preaching to them in their own tongue about how to improve their ontologies. And that message is easier for them to swallow than do it or else. We can keep communicating, we can have applications out. Version control is still a problem, but they by their own light see the issues. They start fixing them. And the defend team is doing this right now. The GIST team has been doing this too. IES, I mean, they're gonna have to, right? They don't even have axioms for that theory. If we're gonna map, they need axioms. And that's gonna make it clear to see, and we can put this in the recording, the various use, mention, errors they make in their textual definitions.
Good. So the beginning of what you said proved my point. So that took years, and still we're not very far along to reach a point where mapping technology or mapping engineering is a mature discipline. We have an extreme shortage of good ontologists, which is going to be economically most viable in terms of using that limited resource into maximal benefit. So with the GIST, I think you have a special case. You have an organization which has a long history, which is pretty clear in its basics, which saw a need to become compatible with BFO. Supposing I were to say that what they are going to end up with will be a new version of GIST, which has BFO as a proper part. Is that a coherent description of the end result of this mapping work with them?
There may be a theory that includes both as proper parts, but I wouldn't want to say that because it's the way the mappings I understand the best case mapping stuff is they try to take their space of like their models and project them into our space. We try to do the same.
Yeah.
That may end up, I don't think this actually happens in GIST, but that may end up being that they project something outside of entity. In fact, that's how we found out the information issue, because they were like, oh, we have to do this thing that doesn't fit under entity. And we were like, oh, no, and information. And they're like, oh, we were very confused. And so I think there could be cases for sure, maybe not with them, but with others, where they might project so that they have a theory that's an extension of GIST that has BFO as a proper part. Or not.
No.
Gentlemen, what do you mean by proper part here? Importing the ontology?
So two groups, both of which are quite sophisticated in their ontology methodology, are attempting to create mappings between the two. Now, a mapping, I take it, is a round trip mapping. Now, if you have a round trip mapping, I do not see what the obstacle is to just putting the two ontology systems together and make one ontology.
The round trip sometimes will work, and they're taking their like a class, and in BFO if they're projecting it as that it's separated as two classes, like it covers multiple ground, but like a disjoint union of them. So the instances, there's no intersection of the instances, but it's like both of those. So in that case, it's something of a labeling difference. But ultimately, all of the mappings should be like literal translation definitions, so that you do have something.
And do you have that with GIST?
Part of it, yeah, and part of it with provenance component. But the only reason I've seen nothing in GIST that would suggest we can't. They're just updating it now, and same with the provenance component.
So the end result of a good mapping, you agree with this, should be that we can put the two ontologies together and make a new ontology, which is agreeable to both sides.
Yeah, and I think that when I'm thinking about putting this into an application, that's my aim. So an example that I used at APL, I won't name the ontology, but I was at some point asked to take another ontology team out. Someone we know and love who is playing ball now. But that was my task.
With a good cop or a bad cop?
With a bad cop. And so I know how to play bad cop, but I was asked to do this. And so what I did was I More broadly, they asked me to take the teeth out of debates over which ontology to use. And so I constructed using OWL a mapping, like translation definitions between them, and then I fed this into a UI where you can just push a button and reconstruct their ontology or reconstruct BFO for the same data set. And I needed that a mapping between them, an actual equivalency.
Yeah, so
mapping
this is
between them.
I'm drawing from what you're saying, for everything that you're saying, that you don't believe in mapping at all. You believe in having BFO serve as a top level ontology, which has an extension, which is gist, for instance.
So that is one way of looking at what I'm saying. That is the way I intended.
Okay, I believe in mappings understood in that
Yeah.
sense.
So I think it's broader than ontology. So like in the dialogue January last year, I gave this talk where I was like, there's not one ring to rule them all, but I said DFO is at the core, and you can take your taxonomy, you can take your relational database, all of your ontologies. And the point there being like, if we have anchors into which to map, we should map into those anchors. That way we're not mapping into all these other sorts of things. There's this two end squared problem.
So, but that just means we choose which ontologies at the lower level gets to be the one which is blessed.
And this strategy, this goodish cop, this surreptitious strategy, ultimately, I think will have the effect of having groups map into a common anchor. And over time, we'll have this virtuous cycle of.
So we have a couple of comments. So Claire, that's from the earlier one. Is there a distinction between logic and philosophy such that ontology only needs logic? No, you need realism and you need the ability to identify French people. You could say that the principles only able to be introduced through philosophy are no longer required for ontology engineering to be viable. However, we also know that ontologies require reasoners, which still require active philosophical research. So in that case, ontologies require philosophy. Okay.
That's not true. Mathematicians are philosophers. They involve
They use
themselves in
reasoners.
other.
Yeah, maybe. At this time, I would support philosophy as a needed part of ontology engineering. Ontology engineering still needs philosophical foundations to keep it defined. At some point in the future, it will become an applied science or standalone. I envision a chemist at the start of chemistry to a current chemist who needs no philosophy training. And then we have in support of mappings, mappings merely give extra life to bad ontologies. Maintaining the mappings requires constant maintenance. This is fragile or may result in the mapping needing to be redone or the ontology to be rebuilt.
So I've been on the back foot for this mapping dispute on purpose, but let me take the stronger approach. So why mappings? So we're well aware that privileged perspectives on the world can get us into trouble. We're well aware that embedding privileged perspectives on the world in machines can get us into trouble. We're very well aware of that. Having one single anchor into which to map, like BFO, will get us into trouble because it will turn a blind spot or create blind spots for other ways of understanding the world. Now, this might not seem so problematic when dealing with well understood sciences or research, like maybe physics, but in areas where the science is less understood or less developed, like psychology, it can get us into a lot of trouble. Now, what I would advocate for is taking the different perspectives from different groups and rigorously characterizing them so that we can map between them or switch between them so that we can like inspect the theory itself on its own terms and try to understand whether this is true rather than that. We use this in combination with empirical evidence to abduct to the best hypothesis for which theory is correct. Because right now, in various sciences that are underdeveloped, it's just not clear which theory is abductively preferred. And so we need these multiple perspectives. We need, I think, to carefully characterize them. In fact, I think it'd be a boon to sciences if we were to step in and rigorously characterize those fields, just like it had been a boon, say, in physics, when David Hilbert went in and said, I'm going to re-axiomatize all of Euclid and lay a firm foundation for modern physics so that other researchers don't get confused about what's properly within the scope of physics and what's actually mathematics. And for that, I think, to really do that across complicated theories, complicated sciences like psychology, I think we have to allow for the rigorous characterizations of different perspectives that can be mapped together to highlight differences and similarities.
All right, so from the very beginning, I have insisted that everyone should use BFO. However, if anyone has an issue, a problem, a structure, a science for which BFO does not serve the needed purposes, then I would work very hard to change BFO, to expand BFO in such a way that it does serve the needed purposes. Because I don't want BFO to be a straitjacket. I want it to be a useful tool for everybody. Now, this is just a story. Oh, it's a true story. So there is a group of, I think they're still a going concern, although I've been told that they may be losing their funding. A group, these are in Italy. Italy seems to grow ontologists. It's called the EMMO.
Oh,
MO.
MO.
Yeah, what does it mean? Several things. Initially, it meant European materials modeling ontology.
Yeah.
Then it meant something like excitingly broken. I don't know. But it still began with an E. Element, yeah, it could be. They claim it's a materials modeling ontology. They claim to be a top level ontology. In other words, everything in the universe can be captured. Everything in the universe can be captured by EMMO. Therefore, EMMO is a top level ontology. There is even an argument why they can achieve this. The argument is they are based on quantum physics. And since everything in the universe, including Beethoven's Ninth Symphony, is part of quantum physics, then they are a universal and therefore a top level ontology. Now, I've seen their ontology of quantum physics, and I was not impressed. It's made of first order logic axioms. Feynman had such axioms, they borrowed from Feynman, but I still was not impressed. All right, so there is this ontology, EMMO. If we take the definition of top level ontology from the ISO standard definition, then they are not a top level ontology because they don't follow the rules that we put there. A top level ontology should be small. Because if it's large, it will deal with topics which are not properly part of the top level ontology because they are relevant only to one single domain or science or group. But now, I think you all know that I have this German collaborator called Jobst Landweber. He is an expert in quantum physics, a real expert. And he and I are working on whether BFO can be used as the top level of a quantum physics ontology. At the moment, the answer is no. So that means I either give up the claim that BFO is a top level ontology, or I extend BFO with what may be just 2 extra terms in order to make BFO compatible with quantum physics. Now, in neither case, you see, do I sneak off into the corner of mapping. That's not allowed.
So, not allowed aside, maybe this is the topic we should learn more about. You say BFO can't cover those cases. I think it can.
You mean quantum physics?
Quantum physics, yes. And my
I'll
understanding.
give you, all right, then let me give you a very simple example of a term for which I think BFO has no account of what it designates. The term is pi. What does pi designate?
A rational number, a transcendental number.
Well, what is that in BFO?
It's an information. It's a generically dependent continuum that's not about anything.
Okay, so that means that it is there exists concretizations. All GDCs have concretizations. What would be a concretization of pi? I'll give you 5 minutes.
I mean, I don't need to. So you say concretizations. If we're good, there's going to be a change. It doesn't have to have a concretization. That should be the change for the generically dependent continuums. It can be in a concretization.
Oh, you mean we changed the definition of GDC so that GDCs could exist which do not have concretization?
That's right. So in the pattern, the strategy here would be that about the one from the About the Unreal paper, just to
Yeah.
here.
Okay, Oh, so actually what you're proposing is part of what I think might be a solution to the quantum physics problem. But I would express it not as changing the definition of GDC, but adding a new term, namely unconcretizable quasi-GDC, for which Husserl has a very good name.
What's the better name?
He calls it an irreal entity.
An irreal entity.
Would it be under BFO entity?
Oh, yeah. Yeah, but that's true.
So BFO is already covering everything. It doesn't have all the
I know,
subclasses.
but there would be this pi, which is not falling neatly under any of the existing classes.
But capability is not currently in BFO. It will be.
Oh,
added.
but every capability is a disposition. We have this position, you know. Husserl doesn't use entity. In German, irreal is a noun.
You think it would go under entity and not under generically entity?
No, because the GDCs live in the land of concretization. So to have a non-concretizable GDC
is better than having an irreal entity.
well, in English, we have to call it irreal entity. Maybe we'll find a better word.
But is it not,
There are many examples of irreal
is it
entities.
not a pattern? Some kind of like regularity?
You're waving in exactly the right direction.
Yeah.
Can you say the mind concretizes numbers?
Numbers are easier. So the number 2 is concretized by this group here. But there is nothing in the real world which is concretizing pi.
What about the perfect circle
Have you seen a perfect circle
Yes.
recently?
on the screen? There's a white circle and a
You
white
think
circle.
that's perfect circle?
Yes, it's white and a white background.
So
No.
let's walk through the
And I'm not
story.
joking.
Concretization of Harry Potter.
Yeah.
So, in that about the unreal paper marking, there's an aboutness going on, but there's just this fictional entity. And it's about,
No,
what
no.
it's about is an
No.
intersection of types.
You and I just wrote a paper called
Yeah, that's what I'm saying.
About
So why,
the unreal.
why wouldn't we take the same strategy for the transcendental numbers? They're fictional and they work the way, not that.
Oh,
they're
because
fictional, but
then
they
you're
work-
throwing away the whole quantum physics.
Well, isn't pi?
The whole of quantum physics.
Uh-huh.
I'm moving way too far away from what I'm competent to talk about. But the whole of quantum physics ends up being like only in a
Oh,
more
yeah.
twisted.
Yeah, right. But like, even in the simple example, why wouldn't we just treat it, again, not like pi is a fictional thing, but why wouldn't we treat it on the same model as we would with fiction and simulation and these other?
I don't think we would be doing justice to the nature of quantum physics. In other words,
Go
we
on.
wouldn't,
Go on.
this topic is not on the list.
I know.
As a moderator, it's true, we are a bit diverging from mapping. So
Yeah, but-
if you can find a way to
bring it back.
in a sense.
Yeah.
All right, so I do not believe that quantum physics can be mapped into BFE.
Okay.
As it is now.
There is
As
no
it is now.
ontology. Well,
So Job thinks we may need a whole new ontology. I'm confident that with a bit of addition, we will be able to get very far in the direction of dealing with quantum. In the weak sense that BFO deals with anything.
So back then to the mapping, there is and I take your point, BFO, if there's some modeling out there that, is not obviously covered by BFO, there certainly is we're ready to update, we're ready to revise. Like nobody's claiming BFO has like the last word, it's being developed, it has been developed. So there's that position. There's also the fact that there are lots of models. People are going to model as they model. They always do. This has been the case. So even though it's a less than ideal circumstance, people have picked their own models and they build applications with them. We do have to find some way to work with them, and we do have to find some way to map between them or work or like in specific applications. And so in that sense, mappings are crucial to get people on board with what we're doing and see the value in it. Now, ultimately, if that just means they're mapping into a common structure like BFO, I'm happy with.
Would you say that the Provo mapping was just mapping into BFO? In other words, demonstrating the compatibility of Provo with BFO?
Demonstrating the compatibility of an extension of BFO, an extension of Provo.
What's the extension of BFO look like?
So whatever was necessary to provide the ground for this, the projection. So like, and you build it out of the classes for BFO. So like BFO is a weak theory formally.
Hmm?
It's open. Bravo is not that strong of a theory either. And so it's not hard to find, within the space of the BFO models. Something
Okay, so you
that-
showed that Provo was compatible with BFO.
Yeah, and vice
Okay.
versa.
Okay.
Yeah.
Am I interested in vice versa?
Okay, just to remind the major points of this debate, Barry argued for the fact that actually mappings are useless or they are basically castles of sand. So if they do anything good, they won't last because there is versioning between ontologies. And John said, yes, true. Mapping is not a discipline itself that is structured. Maybe it's part of philosophy then. It doesn't have a methodology, but there is a promise.
Mhm.
So
In a direct application.
yeah, direct application. So maybe it will be good for ontologies.
I would say that John's position is a workable position precisely because it does not see in mappings the universal solution. It wouldn't make sense. Anyway, we don't need to go into that.
Okay,
That's
we can
Let's
move
see.
to the next question.
You can choose which side you take now.
And John will be choosing.
AI fear is justice. So you just wrote a book.
Well, this is, you have to pick a side.
I know, I'm gonna pick the opposite side of your book. So you just wrote a book about why we shouldn't be so worried. So that's the position you should defend, and I will defend the other. I will say that AI fear is justified, and you should all be afraid, and very, very afraid.
All right. There are some people who believe that guns are dangerous, and some people who think that cars are dangerous. And so we should be afraid of guns and cars. But that obviously is not quite the right inference. We should say the correct inference is to say that we should be afraid of people who can't drive very well, who have cars. And we should be afraid of people who can't control their emotions very well, who have guns. So it's people that we should be afraid of, not cars or guns or any of the other things that can kill people. And now AI, I think we have even less reason to be afraid of people who have control over AI because AI is much weaker than people suppose. Now, there are one or two ways in which AI can be used in such a way that we could reasonably be afraid. So an example would be a massive drone strike in which tiny drones controlled by AI from a remote location are carpeted over a certain area, say Kiev or Moscow, during the night. And then they are, again, through AI, they're brought back to life first thing in the morning, and they're in all kinds of horrible places, and many people die horrible deaths. That kind of thing you probably couldn't carry off without AI. However, that kind of thing, which is so horrible, is the equivalent of the use of weapons of mass destruction. And we already have treaties which forbid people using weapons of mass destruction. There will be treaties which forbid using AI in certain narrow, limited ways to bring about mass destruction. The AI systems will never take over the world. AI systems will never devote all human energy to making paper clips. All of those stories are just fear hype.
Mhm.
So in other words, you make people interested in AI and all its powers by making them afraid. But you shouldn't be afraid. It's a Turing machine.
Mhm.
What can you expect from a Turing machine?
All right. So one quick question. Is fear in nuclear capabilities justified?
I think, given that there are quite stringent limits on the use of nuclear weapons, in other words, we're doing the best we can to control the people who are in control of them. And I won't say that we've done a good job so far, but we have done a satisfactory job. Then no, I'm not afraid of nuclear weapons in the general, just as I'm not afraid of meteorites crashing into East Amherst or
I did grow up during the Cold War where had to do drills where we were hiding under our desks. I mean, now it's
Yeah.
school shooters, but like I remember when the alarm would go off and they'd say, everybody hide just in case there's, a bomb going off. This desks are gonna protect us from that.
So I grew up at a time when I could visit all of the communist countries, and I did.
So, okay, so fair. AI, I think is relevantly different from the other items that you mentioned on your list. And I think there's truth in saying exactly the point that you said, which is, guns are per se the problems, the people, and the lack of emotional regulation and whatnot, just like knives would be, just like, vehicles would be in various slaughter and manslaughter cases. The concerning part is that relevant difference where the tooling that is built out of AI, the ease at which you can facilitate certain technological improvements and advances like drones flying on their own, and the kind of like almost somnolence that engenders in our human capacities to reason and think critically about what's going on, and that care and ease at which we give over our trust to AI. That's the worrying part. We drive and we pay attention. We hold guns and we pay attention. We get training. AI, what's the training? AI, we want it to do the work for us. We see this now with GPT. You write papers, plug it in, write this for me, do this for me. We all know it's already having an impact on critical thinking for students. It's just going to get worse and worse for us as it gets better and better in the modeling. And so that ease at which we're willing and inclined to hand over our hard lives, these tough decisions we have to make to AI, whether it's great or not, that's the thing to be worried about.
I only use AI for good purposes.
You were not a generalizable human being.
But again, if it's only those people who don't know how to use AI for good purposes who are using it for bad purposes, then that's not something to be feared. They are going to be the ones who suffer. I think that the number of really creative scientists, for instance, will not be affected by. On the contrary, they will be actually supported by the powers of AI. So science, that's actually one of the topics on the list. Science will.
The good scientists, though.
Yeah, well,
They're not.
There are lots of bad
There are
scientists.
lots of bad scientists.
They're there anyway.
And they're going to get worse.
Yeah, well,
Just like there are a lot of bad philosophers.
We can't-
A lot of bad engineers, they're going to get worse. What happens is they're going to set us up with research that we have to sort
the
through.
question is whether that is a reason to be afraid of AI. And the scenario that the book is all about, of course, although we hardly mention it, is a scenario in which AI takes over the world.
Yes, right.
That scenario we do not need to fear for 18 different reasons.
There's a sense in which what I'm describing is kind of like dumbing down of the critical thinking, the handing over of trust. There's a sense in which that is a subtle takeover. As we hand things over to AI and then trust AI to do things, and then not only that, but like we agree with the decisions made. Like you can imagine, not too hard to imagine a scenario in which we've handed over our differential diagnoses to AI, and it tells us to take this sort of medication, give this sort of medication to our daughters or whatnot, and then something goes wrong. Well, I mean, that's okay. Sometimes drones fly over Kiev and then go haywire. We tried our best, right? I should still be afraid. I should still be concerned of a world like that where I'm okay with coping with those kind of calamities. That's what I'm worried.
So why are you worried and I'm not worried?
I think you might be thinking about AI in the AGI sense, like, which I agree with the points in your book. Hey, I'm not worried about those things that like Bostrom is pointing to or folks like that. I'm worried about this kind of subtler case, this kind of slow depreciation or like discounting of our critical thinking capacities.
So not AI as a weapon, score point. You made your point and John agreed on that basically. Not AI as a singularity and replacing human beings put them in a bottle or something, but AI is a drug that are a disruptor of
All right.
the
So
economic.
let me defend the AI fear is not justified position even against these kinds of insidious developments. So let's take the way in which students become lazier. because they don't need to do any real work anymore because the ChatGPT. Soon there will be academic institutions. In fact, I think there already are academic institutions which just forbid people to use computers. Or they can forbid them from having an internet connection. Lots of universities are including this one, because I'm going to do it, are setting up practices where we have oral exams rather than written.
Very Italian method.
I don't have anything against Italy. I was in Italy 6 times last year. So human beings will find an antidote to these insidious developments. And there's a lot of AI hype, both fear hype and joy hype. I don't know what the opposite of fear hype. Jobs wrote a book about that, did you know?
I did not know.
Under a pseudonym. It's called the hype
It
cycle.
doesn't surprise me.
The opposite is just hype.
So look, there's some cases I can point to that I think at least make me a little worried about that optimism. And so it's the impact that I see on algorithms, the focus of algorithms is developed by things like Facebook and TikTok, how they target your attention, how the students growing up.
Yeah, people have noticed that. That
Yes.
was a necessary antidote.
And it's
will be
a-
built in due time.
Are they? Like our markets aren't incentivized to stop Meta from doing that. And I mean, we just
The very
lost
fact that
the
it's been
TikTok, you know?
exposed and talked about means that the first steps are being taken. Much worse would be if we didn't know about it.
Okay, I mean, so I'll grant that maybe, but I think these are insidious in such a subtle way that's going to be hard to prevent.
Yeah, this is
And
just fear hype.
I mean, you say that, but you're like optimism hype, like, oh, humans will find a way, but like what I'm pointing to is we'll find a way on your analogy with nuclear weapons, find a way to cope with this bad situation that we can't really solve, but it's okay. Sometimes people die of collateral damage. I guess it's fine. Now,
I didn't say it was
we didn't want to,
fine.
but
It's
previous,
sad.
but it's reasonable to be upset about a world in which we have to cope with such a thing. Just like it's reasonable now to be upset about a world in which we have to cope with TikTok. But that's the world we're leading to.
So does TikTok worry you?
Yeah, it does. There's like increased incidences of suicide ideation.
Yeah, so you have to
depression,
be
and stuff.
a good parent.
I mean, I understand, I get it. I mean, here's not coming near TikTok, but I'm not saying there's a causal connection, but I'm saying there's some positive correlation between the expanse of this kind of attention-seeking, attention-grabbing technology and COVID, lack of interpersonal communication, all coming together that I think is at least
Yeah, no,
related
that's
to.
all fear hype.
I mean, fear hype, but with practice, like what else is the explanation for the suicidal ideation, the depression, the lack of desires, like motivations?
Certainly not AI. The problem is that I don't really think that AI is going to be bringing very much that's good either. So it's bringing about bad things.
Mhm.
We both agree it's bringing about some good things, few good things. The insidious bad things that it's bringing about, I am optimistic enough to believe that human beings will find. Parents, for instance,
Mhm.
school systems. There are school systems in the country which don't allow the kids to bring phones into the school. Those measures, little by little, will serve as an antidote. And then in the end, it will be not fashionable. I'm sure the phrase not fashionable is not fashionable, but whatever the current phrase for not fashionable, not rap, is it? Or not?
Riz? I don't know.
Whatever is the current phrase for not fashionable, it will not be fashionable to use TikTok in 5 years. I predict that. I would bet real money.
Okay, I would call this event. There was like, as in the previous discussion, the future mapping will be good and the future prevention, so AI for common citizens would be better in some way.
I think you need to write into the book.
Yeah, it'll be an interesting.
All right.
I think it's very good.
So which side of this are you going to
So
take?
for the next discussion, that will be BFO is too slow to react.
I think that BFO is not too slow to react.
Okay.
So that I don't know, BFO is not too slow to react. BFO is very slow to react because there is a gatekeeper, and the gatekeeper is me, and I am very busy. So I don't have, I used to be able to deal with all BFO questions more or less immediately. I have to confess that there are some questions, not, I believe, central questions, not questions which have to do with the OWL version of BFO, questions which have to do with the first order logic version of BFO, which I am not devoting, I won't say any attention to, but I'm certainly not devoting sufficient attention to. That means that in any case, we have to find another strategy for dealing with the first order logic side of things. And we have to do that also for a number of other reasons.
Yeah.
But I'm going to defend the view that we are not too slow to react. I think it's good that BFO is slow to react, because if BFO made changes too often, that would be a disequilibrating factor in the use of BFO, because we have more than 700 users. All right, so we have all these users. If we update BFO too often, we will disappoint our users. We then have the aficionados of BFO who know what they're talking about, of which there are about 6 in the world. The 6 people who are the aficionados need to continue planning for the post-Barry Smith era, which may have started already. You can no longer rely on Barry Smith.
So BFO is not too slow.
No,
Slow
that was
enough.
it's exactly slow enough.
I'll take the other side and say that it is too slow.
Go on.
Here's why. So you've cherry picked just changes as a marker of whether it's slow or not. And that's not the only thing that encompasses BFO. People have requests, they make suggestions, they sometimes want things added that aren't added, and we don't respond to them fast enough. And we also don't provide documentation sophisticated enough to help them see their way through their own fly out of the bottle, right? And so in that respect, we do them a disservice. They have to go build on their own. And so it's not changes so much, but response time. Response.
Okay, and I don't think that I am receiving these signals at all, really. So the signals I receive tend to be signals either suggesting that there might be an error or requesting that an error be changed, which would mean a change in BFO.
They do come up on the issue tracker, but Alan and I are pretty good at keeping track of that. It's come up in my experience more often in the BFO CCO office hours. But there's a desire there's a desire for design patterns for BFO, documentation around BFO. I have like Tina doing some of this, but it's only so fast, right? We're all really busy.
Yeah, and we are writing a book.
Exactly.
Which will deal with
this will deal with
a lot
of
of
that.
those.
But it is.
But that will be at the same time that will be slowing down.
That's right.
The reaction to it.
But when I go and give talks when I gave the tutorial at NACE, right? Like gave them case studies, tomorrow we're using BFO. The next question is give me a pattern that I can use that I can just plug and play. And we only have so many for BFO. We don't have a lot of design patterns for BFO. That's documentation people want, documentation people need. And I say we're too slow because they keep asking for it. They keep asking the same question.
So I don't live in the design pattern world, unfortunately.
Yeah.
You can blame the Italians.
I'll blame the Italians. Italians, BFO is too slow to react in this respect.
Every other report is too slow.
Oh yeah, BFO is the fastest of them all.
Yeah.
So there is, like, I agree, stability is key. It's important. Python is slow to react too. Python also has a vibrant community of people who create patterns and recipes. So there are 2 sides at least to this. But Python itself doesn't change that often, and it's good because it would break a lot.
Yeah.
But there's still these patterns that they hand off to the community. We can be doing more of that, and we can be doing it faster as we get requests. And we just at this point don't have the staff really to do it. We're fighting the good fight. But there's my case. Under my breath, I don't actually think it's too slow. But I'll say, for the sake of this argument, BFO is too slow to react because of this documentation.
So your common premise, BFO is slow, but it's a bad thing, and it is a good thing. These are 2 actually conclusions Yeah,
So I would add one footnote to the discussion of the book. We are writing a book, a handbook to BFO. It will contain responses to some of these requests for design patterns and so forth. But it will not do much in the way of changing
Yes.
BFO. So,
Let me add more fuel to the fire on the side of it. Okay, in contrast, there are companies, organizations that are pushing ontologies and foundries that are much, much better than we are in documentation and design patterns. Palantir is fantastic at developing design patterns. They have entire marketing teams that do this. You know exactly what kind of exactly what the model looks like. They have all of this, and if you need something, they'll build it for you because they have tons of people that do that. In that respect, if we're thinking about implementing BFO across, say, I don't know, the DoD and the ISP space, we are far behind in that. And so we are too slow to do it.
that's a personnel question.
That is person. I think throughout the theme there is personnel staffing question. I don't think it'd be reasonable to put that on my, Alan, Burner, there's too much to do. This is one of the reasons why this past year I've been focused on identifying funding to support this, because we just need to hire people who are dedicated to this if we're going to compete with these other organizations.
So final point, BFO is really too slow, you basically admit, even if it's not that slow compared to the environment and the other ontologies.
There can never be AGI.
There can never be AGI. It's a question that we already touched.
Okay.
Now, if possible, I want some of you to take an opposite position compared to
But I
the one
want
that
to
you.
I want to argue that there can be AGI. I think I can grant a lot of the stuff in your book because I do agree with your positions on complex systems and whatnot. But here's my opening salvo. Are you familiar with this short essay, The Bitter Lesson? Okay, so there's this essay, I think it's Roger Sutton, he wrote, it's kind of popular in computer science circles. Points, he's saying that the bitter lesson for computer scientists is that, as advances in AI and programming and whatnot have developed, as advances in towards AGI, which have unraveled, we learn over and over again that the model of artificial intelligence doesn't look anything like we thought it would. And so we first were inspired by neuron models and whatnot. Even before that, inspired by symbolic representations. And then we realized it's more statistical. We did Markov chains and stuff like that. And so it's a bitter lesson. He says we have to learn over and over again that real advances, real good outputs, real progress just doesn't map up to what we envision a priori. So I can take the positions that you say seriously in your book, but I just don't think that AGI is going to look like the topics you described in the book, the complex system. I just don't think mathematically that's what it's going to look like. I think we'll have to come up with a new method for it. I think we'll have to come up with something else that will be something that we understand, or we maybe don't understand, that reflects AGI. But I can't take the pessimism about math, the pessimism about
So this is Father Christmas.
Yeah, the pessimism about our understanding of neuroscience. I can grant all that, but why in the world would I think a model of AGI would look anything like that anyway? In 1903, when we were the Wright brothers did heavier than light, travel, when they launched the first airplane. 2 years later, Scientific American was still asking for hard proof because people didn't believe it. Everybody thought it was impossible. I think it's possible.
I think AGI is impossible.
Yes.
And the one standard argument against that view is that it goes something like, Einstein thought that nuclear energy would be impossible. Ha, ha, ha. So Einstein made a mistake because he said something was impossible. I say something is impossible, therefore I'm making a mistake.
That'd be a bad inference.
That actually has happened multiple times in the reviews of the book, that they think that we're making a thesis of impossibility. Mm-hmm. People who've made such theses in the past have been shown to be wrong. But the first thing that to be said about that is that many of them were right. there can be no perpetual motion machine and so forth. But then the other argument, this actually was my motive. Jobs actually he's not a good cop, nor is he a bad cop, he's a weak cop. In the sense that he wanted to call the book something like, oh, this is unfair to Jobs, but something like AI may not be possible. It may be possible, it may be impossible. I wanted to the really bad strong cop and say, no, it's impossible. And the argument for that is if you don't take risks, you will never achieve anything. So the thesis that AGI is impossible is that it's a bold thesis designed to provoke people. And then the subtext of that is that in the book, I don't think this chapter has been read by anybody, but in the book we describe how to build AI systems. And maybe you've read those using methods that Yelps was using in his company. And those AI systems do indeed work, and they do wonderful things, but they're not AGI. Now, another argument which has been put forward, and I thought you were going down this road, but you took a weak cop role. So your role is something like there might be fairies around the corner. There is an undercurrent through the book which says, if AI is going to be expensive, therefore we will want it to serve human purposes, and therefore it can't be too remote from what we humans want and like. And so they built AI systems which really do address human purposes. They don't really address purposes having to do with motion, so robotics is still very much in the background. But they have to use language, they have to be such that you can give commands using ordinary language. And they do that fantastically well. That's one of the great achievements. But the underlying goal, we believe, but there is some evidence, which he's going to document when he does his lecture in a couple of weeks. Here, there's an underlying motive, this is another topic of discussion, among the gods of AI, to create digital consciousness, because they want to be immortal. And if you want to create digital consciousness using AI, it's no good to be a magic fairy of the sort running processes that we have no notion of. You have to be close to human consciousness. Your model has to be human consciousness, which means emulating the human brain, building machines that work more or less in the way that humans work, only better. And that's what AGI means. And then all the arguments in our book against the possibility of emulating the human brain will kick into play. The human brain is the most complex system that we know in the whole universe. It's a complex system of complex systems, and of trillions of other complex systems. It's really complicated. And it took how many billion years to evolve? So
Sure. I mean, I don't know how much weight to put on the digital immortality line must have, like that requires the actual representation of the human brain. Therefore, AGI.
well, that's the definition of AGI. Remember, AGI is, that's one of the definitions. AGI is an artificial intelligence which would be at the same level as human intelligence. So it
At
would
the same
be,
level in terms of like what
it
it's
can do all the
capable
things,
of,
all the things that humans can do. Now, sometimes they say all the things which are commercially relevant that humans can do. Sometimes they say all the cognitive things that humans can do. The commercially relevant one is easy to smash.
I'm not sure why, just like neural nets and like back propagation and attention mechanisms probably aren't how our brains work when we're like identifying patterns. So like deep learning, that model isn't probably not
Oh, I agree.
Why would I think that AGI has to model what we're doing? Why would I need to understand this complex system?
It has, so if it's going to serve the purpose of digital immortality, it has to be
That's a
stuck.
different topic.
Yeah, well, we'll be coming to that topic later. I think it's relevant to this topic. AGI is meant to be the first step on the road to the singular.
Yes.
And AGI may be achieved without modeling human consciousness or the human brain.
Yeah.
That's true. but it has then to be a stepping stone along the way to solving that problem. And that problem is insolvable because of the complexity of the human brain
Again, I'm not.
or any biological
So
system.
again, one, I'm not sure why I'm committed to the modeling of the human brain for AGI. So it seems like we can develop some models, just like we're doing with like recurrent neural nets. We can make representations or like machinery that works in certain ways, ensembles together, that give us the same outputs that we expect with certain inputs, just like we do, without modeling the brain. Like I can agree with the complexity and like not being able to model that.
What about consciousness?
Is that what we're trying to do with AGI? Is AGI?
No, but you've got to think to keep it in
I
mind.
agree, but I'm saying there can be AGI, not consciousness.
Would
Like, I know
AGI
consciousness.
include the component of ethics?
I think it could. I mean,
Can you have
humans
ethics
input
without
that.
consciousness?
Yeah, I think so. You can at least ethical behavior,
I don't think it's ethical if it doesn't have a conscience.
but you've never taken an ethics class.
All right, so
I think there's one other piece of this. So, and it's in terms of like, it's right in line with that better lesson, which incidentally, I don't agree with, but, I'm taking this side. So I actually agree with you on this. But there's also this factor, and I think you may have mentioned this, about errors. So like we design research programs in certain ways and we like aim towards goals like AGI. Maybe if we get this piece, it'll lead to these other pieces. But I think often we overlook the fact that we are error prone and make mistakes, and it's important, like a mark of genius sometimes, when you can recognize when a mistake is actually taking you farther than your original path would have. Like Hankins' incompleteness proof was a mistake. He was trying to do something else, and he was like, "Oh gosh, this is a simpler way to do Gödel's proof." It's brilliant, right? Now everybody learns it in textbooks. Like that kind of recognition is important. I see that throughout the history of science, and that's taking us in detours that we wouldn't have expected to go down. I could see that here on the route to AGI, these errors and recognition of them is taking us to a path that we wouldn't have expected, that probably won't look like the human brain, but nevertheless will get same outputs with the appropriate inputs that we would expect from AGI.
I'm not going to argue against that. So
Would it be that AGI can be defined by the tasks that it solves instead of the origin and the fact that it's simulating a brain, the most complex structure that we know in the universe? So, for example, as in ML, people talk about regression, classification, clustering, and so on. These are, we can talk about robotics as well. These are the tasks that AGI would be very good at.
yeah, but they're not. See, remember, AGI is measured against human intelligence. Human intelligence doesn't involve those kinds of tasks. So I've been working on this task question in the last weeks. So my example is trying to get planning permission to build a hotel in Buffalo. That's a human task, which is cognitive and economically relevant. And I have a map of all the offices that are relevant if you want to get planning permission for a hotel in the Buffalo City Hall. There are something like 16 different agencies. There are also politicians. And in order to get planning permission, you need to join agencies. You need to have lawyers. You need to have finance people who are well connected in City Hall. To pull all of that together, it's a task which humans do succeed in mastering. But you could never have a computer that could do any of that. Talking to politicians, working out how far you can go with the lady who owns the building next door to your hotel.
Like the soft skills.
Many complex economic tasks involved. Soft skills, hard skills.
Yeah, I'm on board with this. There's a know-how that I think is missing.
Know-how
that's right.
can be a part of economically or cognitively relevant AGI.
Right.
So given that your argument, even if we haven't.
AGI is impossible with the current computer architecture. Barry is correct. At some time there will be advances in technology where AGI may be possible. What is so important is that the attempts at AGI will produce unknown benefits and maybe also unknown disbenefits. Is there something so bad with the new alchemy called AGI Well, we've been trying to address that. And then what if all our systems are optimized so that they can engage with other AI systems? So I guess you're pointing to the idea that while any single computer is a Turing machine, or any single AI has to work within the constraints of Turing computability, you could somehow go beyond Turing computability constraints by tailing multiple AIs together. But you can't. That doesn't get you any further. So now let's move to the next topic.
Knowledge graphs cannot prevent hallucinations.
I am afraid that knowledge graphs cannot prevent hallucinations. So I believe that this is true. They can. So go ahead.
I'll argue that they can. All right, I'll do this in steps and let you fill in. So my first opening salvo. Knowledge graphs provide a rule-based framing for information that can certainly cut down on hallucinations. Hallucinations being like unexpected output from prompts, and we feed into LLMs. And so they often violate expectations. I mean, it's important to highlight that's what hallucinations are. They violate expectations, expected outputs. There's some like boundary cases we can point to. They give bad answers for like math problems. They give bad wrong answers for like ethical questions and stuff like this. We can hard code those rules in. So even though they're like statistical machines that are like statistical parrots, as it were, they're creating distributions of like the next or the next token is supposed to come out. We can nevertheless inject into those models like hard and fast rules that they can't violate. People do this all the time. We develop that's like internal mechanism.
And you're just talking about knowledge graphs now?
Just talking about knowledge graphs.
General.
Using knowledge graphs as like rule-based, like reference to for the statistical distribution. But then on the other side, we can use knowledge graphs as like source data. So we're doing RAG or something. You can like reach over, look at this documentation, pull back. Again, another set of rules as your prompt is unraveling and getting longer, so you can stay on track. So I think all of this, I'm not saying that there are technologies out there now leveraging knowledge graphs that absolutely avoid hallucinations. Anybody that's saying otherwise is lying. RAG, when it was first introduced, people were like, oh, it eliminates all hallucinations. No nonsense on stilts. It didn't then and it doesn't now, but I think it's all pointing in the right direction. I think key to that is knowledge graphs, where knowledge graphs I'm understanding here is like ontological representations with instance data that are rigorously characterizing the formality or the structure of a given domain that we can trust as best as to our knowledge as we can.
Okay, now, if one reads the literature on knowledge graphs, then it seems that there is one school of thought which said that a company could create a knowledge graph for its own purposes by extracting data about the instances of cases that the company has been dealing with. And the ontology then is not mentioned, that these are just home-baked knowledge graphs.
Yeah.
Do you think they can help to prevent hallucinations?
I think they can cut down on some local hallucinations, but I don't think they're going to have the generalized background knowledge that they need to prevent all hallucinations. And I think that's one of the kind of disconnects between knowledge graph development that's done from the bottom up versus the sort of methodology that we propose here at UB, which is more of a sandwiching top-down, bottom-up strategies where you're building the stuff from the ground with an eye towards universals at the top. I think you need both, because without both, you're going to miss the background information that we bring in with continuance and occurrence and material entities of them.
So I am assuming that another advantage that we bring is a reusability.
Yes.
So we could imagine a scenario where we have a foundry of knowledge graphs.
Yes.
Which has been built on a Vogue foundry, or what we call BFO foundry principle.
Yes.
Methodological
convictions.
We could have a foundry of knowledge graphs.
Yeah.
Which is maintained by people who know what they're doing, which is built on the basis of good ontology. Tell me how that would fit with the contributions which come from the AI side. Would it fit only if some customer with a lot of money purchased the foundry protection, as it were? Or could it be that some outside agency puts itself between the knowledge, the AI and the customer by creating this?
I think it will be like to address hallucinations. I think gonna need to intercede at multiple points, between the prompts themselves, the background architectures, and like the way that they're accessed. Because hallucinations are ultimately about expectations from our prompts. You put in a prompt, you ask it a question, and it gives you something that's wildly different, or even slightly different than what you expected. Like it's about your expectations. And some of those are more common than others, like more widely held. Like I have expectations that if I put in what's 2 + 2, it tells me 4. But I also might have expectations about the norms of being in a classroom. Like, and I might ask you questions about that, and it might give me hallucinatory answers for whatever reason. So to address that problem, hallucination problem, one, I think you're going to need to approach it from different angles, all of which can be supported by rigorous characterizations of domains with background knowledge from the top all the way to the domain level logic or formalism that you see with knowledge graphs, to code in the expectations, consequences of the expectations, plans, like what things exist in the domain and all that good stuff. Now you're not going to be able to statistically generate the next token 100% of the time across the board without that background information or those rules intersecting in different parts of these interactions. But I certainly think knowledge graphs.
So why hasn't someone done it? Why haven't OpenAI built that thing?
So I think right now LLMs, they're commodities now. So like everybody's got one and they're like trying to refine it. I was arguing like earlier in the year that in the land of commodities, the data is king, right? And so a lot of the new research to find like niche uses or like real novel applications of LLMs is coming through my understanding, through specialization through higher quality data. Some companies like DeepSeek are using high quality data that's knowledge graph driven. Others are using high quality data that's really well labeled and annotated, like Grok, stuff like that. But I think various groups are trying in the market to identify what the best strategy is for improving the data, because that's what they're feeding in. And at least at one point of this, like back and forth between us and the LLMs, I think there just are, as a matter of fact, groups that are using LLMs in combination with knowledge graphs to the same end. And that's the back end side. And those are the folks who are advocating for various uses of RAG. And Microsoft, for sure, like Microsoft created the RAG library. Like that's where this all kicked off. It's because they saw a lot of value in minimizing.
But that Microsoft library wasn't bolted onto ChatGPT.
No, it was for the community, right? Like everybody was using LLMs. And they're like, look at this graph RAG library that you can just pull in.
Okay.
And so they're like, everybody can use it now. They improved.
So my view of hallucinations is a little bit different. Hallucinations, from my point of view, are answers to questions which are false. And I'll give you an example, which I think wouldn't be caught by a knowledge graph, however strong it was, because it rested on a simple falsehood. So a couple of days ago, I asked ChatGPT to give me a one-page summary of the arguments in our book, the Yobst and Smith book. And it gave a pretty good summary in perfect English. But along the way, it made a remark that we had drawn on Wolfram for some specific thesis. We didn't use Wolfram anyway. So, but Wolfram did work in that space. It was reasonable that we would draw on Wolfram. And so ChatGPT, who was trying to be cleverer than it really is, added a reference to Wolfram. Now, none of the things that you've been describing would have stopped that particular hallucination.
I think it would have. I think it could have, if it had been accessing the source material and looked through the references, it had a rule that said don't put in a reference that's not in the bibliography.
Maybe. That's a rule, right?
Yeah,
That's not.
Well, I mean, a rule that you could encode in a knowledge.
Yeah.
Right. Like so this is not sort of an addition triple that you can add. I was at a demo from the Neo4j people. So Denise asked me, they were trying to sell something to WTI and they were building like some RAG LLM stuff. And they wanted to see, they were trying to get Denise to agree to send it over to the Air Force. And so she was like, I don't know. And so she asked me as a ringer to come look at what they were doing. So I asked them while they were showing me all their bells and whistles. I asked, it was rags, they were pulling directly from the source material that you could see on the left-hand pane. They're like asking questions about this document. And I said, ask it how many paragraphs are in the document. And it scanned the document and accurately answered how many paragraphs are in the document. And then I said, and this is where I thought it was going to trip them up. I said, tell it it's wrong. And then see what it says. And they did. So they said they were nervous. They were very nervous because they saw immediately what I was asking. And they were like, oh, we haven't tested this, started doing that. We didn't test this. I see what you're asking. And it took it a long time to answer. It took it like way long. And they were very nervous about what, but it got the right answer. It said, no, you're wrong. Like, no, you're wrong. It actually was disputing. So I thought, okay, that's well done. But not too long ago, I mean, you can do this with GPT now, right? Like their system was sophisticated enough to where it could correct using RAG. But like, you can do the same experiment with an LLM on ChatGPT, GPT-5, tell it it's wrong. It will agree with you. Tell it it's wrong again, and it will agree with you again. So I'm optimistic about addressing hallucinations like that. I watched the Neo4j guys do it on the fly. Still don't invest in them. It wasn't good for other reasons, but.
All right, so I think that's. Are there any comments on any of the topics that anyone would like to raise? One last shot across the bows.
I agreed with John about AI fear, not so much like these kind of AGI and world scenarios, but especially the way that people interact with algorithms. A fear of mine is like it's unknown how much in your daily life that an algorithm can be influencing you, because on the social media that you interact with, everything that is being presented to you that you're taking in it's all the output of a sophisticated recommendation system of like delivering to you the best way, like the most thing that you're statistically likely to interact with. And that's just very dangerous for a person to be constantly exposed to media of that type. And just among myself, seeing like people my age, there's just interactions between people. It's like people will be interacting with one another and use certain language or reference certain things that as a result that they became knowledgeable about just through their interaction with an algorithm. And something about that just worries me to where like these algorithms can start to be like the curators of like culture or something, where people are just being given all of these outputs, this content. And like back then, before AI, institutions were responsible for like the dissemination of what kind of things people are exposed to. So
Now it's different.
I think so, because
So the AI is still controlled by people, companies with ethics officers and so forth. Whether they follow the wisdom of the ethics officers is
I
a
think-
different matter, but nothing has changed on the role of institution side. It's still humans who are building these algorithms. I agree with you that there are all kinds of fishy aspects to these algorithms, but they're gradually being identified and gradually people are pushing back. And there are humans who can mislead you for years on end. So, but you don't complain about the fact that people have close relationships with humans who trick them and so forth. I assume.
I just feel like it's safer.
You think humans are safer than machines?
Yeah, because like
No.
there's no awareness on the side of the machine. Like things can just be spewed willy-nilly.
Yeah, but
As long
if
as
that's
it
going to be
satisfies.
dangerous, it's because some clever human beings have built some software. So it's the humans again who are the responsible agency here, not the machine. And as I say, people like you are gradually pushing back. They're realizing what's going on and they are setting in motion processes which in the end will bring about a better solution.
What if we have organizations with, malevolent intent, whose goals are to enforce
Humans,
that
yeah.
with humans that whose goals are to use AI in these various ways to maybe undercut, say, the critical thinking capacity. Or
So,
attention of people.
I think that some people in America thought that China was doing something like that with TikTok. And they took China out of the TikTok chain of government. That is a step in the right direction, perhaps.
Perhaps.
That's a reason to be optimistic.
And how about bots? Russia, all over the forums, spewing falsehoods.
Yeah, I'm not in favor of Russians either.
Sure. But the insidiousness, and how do you spot them?
Every generation has found some things insidious.
Oh, I mean,
Television.
for sure.
Think it's
Oh, yeah.
television, what it will
In
do to
books,
our children's
books,
brain.
obviously, books.
Printing.
Obviously.
Writing.
But like
Writing is really evil, said Plato.
That's right. It messes with your memory, right? Yeah. But like I think there's an order of magnitude of the difficulties we're facing.
That's what
now.
every generation.
Well, sure, for sure. And then, but my point wasn't, about the orders of magnitude. My point was what to be afraid of. And what to be afraid of here wasn't how grave the situation is, how hard it is to discern one epistemic position from another, but the fact that we're looking down the barrel of a world where we have to cope with just one more thing, like we've always had to cope with just one more thing, nuclear war. We shouldn't have had to. It's reasonable to be afraid of it. We're now coping with it. Now we have this other thing to be afraid of. Yeah, you're sure. But the point was, should we be afraid? Or are we justified?
We should not be afraid.
Yeah,
We should
but
be-
you're looking
We
at.
should, if we have really strong opinions about these things, then we should join the movement to regulation and so forth, which we will be discussing next week.
Which will help me set up for my stump speech when I run for office and start doing something.
All right,
Very good.
thank you.
So, thank you for your time. Thank let's thank the discussant for their invaluable comments and reasoning of various topics. There will be another session in the future like this one.
Same time,
Fantastic.
same place.
Very good.